Hello, welcome to the second session today in EAMS 2023. We'll just wait another minute or so for people to come in and then we'll get started. We've got a session with Amber Manders from SOWISO, an introduction to SOWISO's authoring environment. This is a software demo really, and there'll be a chance to have a go at that yourselves. We'll just wait another minute or so. Okay, I don't think anybody else is joining in just yet. So we'll begin. It's my pleasure to introduce the team from SOWISO, who make a commercial e-assessment product, which they're going to demonstrate to us. Amber Manders is going to lead the presentation, I think. There will be an opportunity to get have a go at the system yourselves. I think Amber's colleague Ainhoa is going to message people with login details. I'm sure they'll explain what they're going to do. So I'll just pass over to you, I think. Amber.
Thank you, Christian. So let me share my screen. Can everyone see now? Great. All right. Yeah, so thank you for the introduction. My name is Amber. And I'm a mathematics author at SOWISO. And I'll give you an introduction to SOWISO's authoring environment. Now, this may sound a bit vague, so I'll first explain a bit about what SOWISO is if you haven't heard of it. So SOWISO is a STEM-focused e-learning platform. When I say STEM-focused, I mean we specialize in mathematics, but we also have other courses like physics, chemistry, economics, programming, and a bunch of other courses. And this is an all-in-one platform. So we have interactive digital textbooks with also practice materials. And these practice materials, they give the students automatic adaptive feedback. So if they make a specific mistake, like they forget the chain rule, then the platform recognizes this and then gives the student a hint or tells them, hey, you should use the chain rule. But we also have homework, testing, and even exams, but I'll tell a bit more about that in the next slide. And then lastly, we have monitoring. So teachers can monitor their students. They can, for example, see what students are at risk of failing, but they can also see what topics they maybe should spend a bit more attention to, because students are struggling with that. But also students can monitor their own progress. We have things like gamification in a platform that they can gain points if they do exercises correctly. So really an all-in-one e-learning platform, and it is based on 3 pedagogy models. We have incorporated mastery-based learning, guided discovery, and also adaptive learning, but I won't get into that today too much. And the way we describe it often is as a digital teacher assistant who really supports the whole learning process of the student from the teaching materials to Z to maybe the tests or the exams or whatever the required end result may be. So a bit about testing. We try to make online testing easy in 3 ways. So first of all, we make constructing the test easy, and we do that by having very big question databases. So what teachers can do is they can just pick the questions they like from the database and then put them in a test. And even if they don't see the questions that I like in our database, they can make their own exercises. And like I told you before, what's nice about these exercises is that they are randomly generated. So for example, if 2 students are sitting next to each other in a class and they're doing a practice test, If they would do it on paper, then they could maybe look at their neighbor and see, well, they filled in 5 in question 1, so I'll do that as well, then and done faster. But right now, because they're randomly generated, their neighbor's answer might be 5, whereas their answer is 2. So instead, you get discussions in the classroom about how to solve the exercise and not only the solution, which is, of course, great because then they learn from each other. Then besides constructing the test, we also try making online testing easier by making the test taking easier. So our tests are easy to schedule. And there's also a lot of settings that you can change in order to make the tests precisely as you want. And we have safe remote testing capabilities, either with or without proctoring. So if your students are taking a test at home and they shouldn't be able to cheat, then this is possible. And then lastly, we make grading the test easy by implementing automated grading. So the computer automatically checks the exercises of the students and then gives a percentage based on how well they did every exercise. And they also automatically generate progress reports. So you can see how well your students did. Now, last year at the same conference, my colleague Adam actually gave a talk about the potential of formative testing with Bolster Academy. But just to mention that Bolster Academy is the international name of SOWISO, so it's exactly the same company. And if you want, you can still look this talk up on the website. There's a link. Not sure if you can click it online, but you can find it on the website. But today we will do something different. So I'll give you, like I said, an introduction to SOWISO's authoring environment. So what I will do is, after a few more slides, I will go to the platform and then give you a short demo. I'll show you some different exercises types that we have that you can also use in tests. And then we will make our own exercise from scratch. So if we just go back to the previous slide with the testing, we will focus on making our own exercise to use either in a test or in practice materials. And what we also will do is, my colleague Anoa, as Christian mentioned, she will send all of you a message with login credentials so you can log into the platform. You can actually try it yourself. So you can try out some exercises as a student, but you can also follow along with me in making your own exercise. But before we get into that, just two more things that I want to say. I want to give you some numbers. So, like I said, SOWISO is an online learning and testing environment. It's actually a spin-off from Eindhoven University of Technology. And we have more than 10 years of experience. I think we're at 13 years right now, if I'm not mistaken. So quite a lot of experience at SOWISO. And then also we work with more than 60 leading institutions, and this can be universities, but also high schools, colleges, even publishers who then use our Med engine to maybe digitalize their books. And we have about 450,000 students on the platform, which is about twice as much as last year. So we've grown quite a lot. And I think that means that students are happy with it. And then also some numbers on OMPT. OMPT is another project or product that we offer. And this is about online mathematics admission tests. So the idea is that students who want to maybe study abroad in a different country and they cannot really show their new university that they want to apply to that their level of mathematics is sufficient to apply at the study they want. What they can do is that then the school they want to apply to, they can refer the student back to us, where they can take this mathematics admission test, and if they pass it, then they can actually apply for their new studies. These tests can be taken anytime and anywhere. They're safely proctored, so they take them online, but there's no chance of cheating. And we co-developed them with leading admission offices. And there's also a lot of universities and study programs who use this at the moment. So this is also something that we offer. But right now, I want you to join me in making an exercise, or first to show the platform, then to make an exercise. So I hope you got the login credentials from my colleague yet. What you can do is you can go into this website, cloud.sowiso.nl, and then log in with the credentials that you got from my colleague Anoa. If you log in for the first time, it will ask you to change your password, so you can do that. And then if you have any problems or you haven't received anything yet, please message Enoa for me, and then she can help you. So I'll leave this on for just a minute so you can open it and check it out for yourself a bit. For anyone who has managed to log in yet? I see some thumbs up, that's great. All right, then if you haven't logged in yet, please continue to try and do so, but I will just open it up already. So if you log in, you change your password, this is what you see. So what we see on the right is your class. And I've given you all access to 3 classes. We have the basic maths demo class, which is like end of high school preparation for university kind of, well, basic maths class. We have a calculus class, which is, I guess, first year university, like a calculus service course level. And then there is a third class, which is not really a class, but is a page with some exercises, like some different kinds of exercises that the platform offers. So you can see all the different possibilities that we have. Well, I'll just start with one of the actual classes. So this is basic math, and here in the middle, you see all the chapters that are in this class. And if we open one, for example, differentiation, then it expands and you see all the content in this chapter. So we have the subchapters in bold, and then the contents, which are either theory pages with a little paper icon or packages of exercises with a little pencil icon. And this number here on the right, it indicates how many exercises are actually in the package. And what we do with our own courses in SOWISO is that often we make one theory page and then one package of exercises that test the theory that I've seen in the theory page. And as an example, we can maybe look at the sum rule. So I've opened the page here already. This is what it looks like. So we have, you see some LaTeX here, some colors. We have boxes and also expandable boxes. We use these to not make the page so cluttered. So if the student opens this page, it doesn't scare him away immediately. Especially if you have proofs on there, for example. And then at the end of the page, we often provide an example. So we have a question and then a fully worked out solution, which again is about the theory that I've seen on this theory page. The nice thing about this is that they're also randomized. So if you look here, we have the square root of 5 times x to the power of 6. And if we request a new example, then you see that the numbers actually changed. So now they get a new exercise with a new fully worked out solution. Like they can request as many examples as they like. They will be different every time. Show another one. And this is a nice way for them to practice. So they've seen the theory page. For some theory pages, we also have videos explaining how things work. So this is a YouTube video just explaining a worked out example of an exercise where they have to use the sum rule to differentiate. And then lastly, we have the package of exercises. And as you can see here, there are 7 exercises in the package. The students can do, well, all of them. No. And this is a nice example. So this asked for the derivative of this function. And I'll just try something and make a mistake so you can see what happens. So if I forgot to multiply with 7 in the first term, then it will hopefully give me some feedback. But it says the coefficient of x to the power of 4 is not correct. Then, of course, the student has to think, well, what did I do wrong? And I change it. So I maybe write something like this. And then it will say, well, it's almost correct. You get a green check mark, but you can still simplify your answer. So we can do that as well. And then the system will say that this exercise is correct. And if I click this button, then they again see the fully worked out solution if they want to. And of course, they can redo the exercise with different numbers if they want to try again. Now, if they really don't know where to start, there's a few buttons that can help them with that. So they can request some theory. In this case, it opens up the video explanation about the exercise, but you can also show some theory page here. We have hints. So if you click on them, student gets hints, and you can implement as many as you want. This exercise has 2 hints, as you can see. I cannot click this button anymore. And then if they really don't know how to do it, they can click solution, view the solution, and then redo the exercise again with the different numbers, so they can try again. And we don't only have these kinds of exercises, we actually have a bunch more types. So this is what we call an open exercise, and this is also the one that we will make in a minute together. And what I mean with open exercise is that there's an answer field where the student can just type anything. So it can be a number or an equation or a function, an integral, whatever. And the computer will check it and give some adaptive feedback. But we also have different kinds of questions. So this one, for example, it has multiple answer fields and then also a drop-down menu. We have exercises like this where they have to draw a function by relocating some points. Oh, it's a bit slow because I'm sharing my screen, I think, but this is the idea. And then we also have exercises like this one where they have to drag the correct derivative to the function. And this is just a few examples. I think I showed you 4 examples, but in total there is more than 28 exercise types. So there's really something for everyone. Let's see. Maybe this is another one, a multiple choice. Of course, we have those as well. And these also can give adaptive feedback. Now, another thing that I want to show you in the demo is another theory page. This one is about linear approximation. So it's a bit higher level. As you can see, it uses some more mathematical terms. You see that this has some images as well. So these are made with GeoGebra. And this one is static, so students cannot interact with it. But often we also make images that are actually interactive, like this, for example, where they can see how linear approximations work. And the students can use sliders or draw things or input things themselves in these applets, and then they see how the theory is applied. All right, so this was a bit of a demo of some content from one of our courses. If you want to check this out at home, if you think, well, an hour is not enough, I want to see it for myself without having to hurry, then you can use these login credentials that you got today for a month after this conference, so until the 20th of July. And you can just log in with your new password and check this out by yourself. So you can try all the exercises, view all the theory pages in the videos. And what you can also do is go to this other class with the exercise types. So if I open this up, it says some text and then some links to different exercises. So for example, Python coding is not mathematics, but maybe you're interested in that. If you open it up, you can try it out as a student and then see what kind of feedback the platform gives. So this was the demo. Now I want to actually make an exercise from scratch with you, and we will make a very easy exercise, an open exercise where the student has to just add 2 integers together. And to do that, we have to click on Author. So right now we're at home and we click on Author. If you want, you can follow along. If we click on Author, we're in the Author environment, and then we see all the content that teachers can actually add to their classes. So we make sure we are at exercises, and then under new, there is this big blue button. And if we click that, we can make a new exercise. So we'll do that now. Then for the name, rewrite a name. I'll call it adding numbers Amber. If you could just give it a name and put your own first name behind it, that would be great. And we leave the rest unchanged. So we only put in the name. The rest is not important for now, and then we click next. And then you see what an exercise looks like from the back. And you see a lot of buttons, a lot of tabs, but don't worry, we only need a few of them for now. And we actually start with the text tab. So everything that's in the text tab right here is actually what the students will see at some point when they make the exercise. So the title, we can give it a title. And then the question is, for example, something like this. Like I said, very easy, just adding two integers, but then you see how it works. And as you may notice, I use these hashtags here. And these hashtags are actually LaTeX delimiters. So anything that's between the hashtags will be parsed into LaTeX font. Normally, you would maybe use $signs, but because our $signs are already taken for something else, we use hashtags. And then for the solution, we write a fully worked out solution, but in this case, it's just one line, like this. And it's good to note that whatever you type in here in the solution box is actually not what the computer uses to check if the student's answer is correct. This is just the text that the student will see if they click solution. To actually tell the computer what the solution is, we need this step, but we will get to that in a minute. Right now we've input a title, a question, and a solution. So I'll just click View Exercise up here at the top. And then we can see what it looks like kind of from a student perspective. So if the title here, the question, and then if I click solution, I will see the fully worked out solution. Now we have two more fields here. We have pre-input and post-input. And what that does is that, if I just refresh this one, the pre-input shows up before the answer field as text, and the post-input shows up after the answer field. So what I could do is, for example, write 3 + 5 equals, then view the exercise again, and then this will show up before the answer field. Now, we can test this exercise, so we can try and type an answer. For example, 8, which should be the correct answer. But if I check it, it will say that it's wrong. And this is because we haven't told the computer yet what the correct solution is, so we will do that now. And for that, we need to go to the Solutions tab. Now, you see some buttons here. The most important ones are this one, the evaluation type, and the definition. So what this evaluation type actually means, here's a whole list of evaluation types, and all these evaluation types actually decide how the computer checks if the student's answer is correct. There's a lot of them. In practice, we only use a few, but there's a lot of options if you want to have those. And the default evaluation type is eval normal, and what that does is that it checks if whatever is here in the definition field is mathematically equivalent to the student's answer. So if I put an 8 here, and I put in a student's answer that is mathematically equivalent to 8, then it will be seen as correct, and if not, it will be wrong. So let's test that. I can click View Exercise again at the top. And then put in 8. And it will say it's correct. Whereas if I put a different number, like 7, it's wrong. But I mentioned very clearly that all answers that are mathematically equivalent to 8 are seen as correct. So if I put 3 + 5 in here, it will also be seen as correct. And of course, we don't want that because the student didn't even do anything. So we want to fix this. And the way to do this is with feedback. So I have one slide to show you about this. This is how our feedback system works in SOWISO. You may have seen something similar before, but the way it works is the following. So if the student presses check, like check my answer, the first thing the computer does is it checks if the student's answer is mathematically equivalent to the solution in the Solutions tab. Well, if that is the case, then it will check, is there a positive feedback rule applicable to the student's answer? Well, in our case, we didn't make any positive feedback rules yet, so the answer is no. And then it will say it's correct. It's fully correct. You get 100% of the points for this question. What we actually want is that we make a positive feedback rule that checks, for example, if there is still a symbol in the student's answer, so a plus or a minus or a time symbol. And it will then display that feedback rule with an orange check mark, meaning you almost got it correct, but you're not quite finished yet. So let's make such a positive feedback rule and then fix the problem. We go back to our authoring environment where we edited the exercise, and then we go to the positive feedback tab up here next to solutions, and we add a rule. Now you see again a lot of buttons. Some are similar to the ones we've seen in solutions, but the principle is the same. So again, we choose an evaluation type. This time we don't choose eval normal because we don't want to mathematically compare two things. We actually want to check if there's a symbol in the student's answer. So I can start typing and then select contain symbol. Now again, this list is quite long, but when teachers start using this and actually want to create their own exercises, they get a training, mostly from me, about all the evaluation types and also where they can find help. And we also have a help center that for every evaluation type has a bunch of examples and ways that you can work with these evaluation types. So don't worry if it seems a bit overwhelming right now. Yeah, but to go back to the exercise, we choose evaluation type and we say contain symbol. And like I click the information button here as well to get some info, but what it means is that if I choose contain symbol and I leave the definition field empty, then this rule will be triggered with with any symbol in a student's answer. And then we can say, for example, please simplify as a feedback text. Okay, so let's test this rule. We go to view exercise again. And then if I type an answer that is mathematically equivalent to 8, but it has a symbol in it, then this feedback rule should appear. So I can try my 3 + 5 again. And indeed, it will give me an orange check mark and the text, please simplify. And it also says up here, positive feedback rule 1, which is exactly the one that we made. So we see here positive feedback rule 1. But these yellow buttons are only things that authors, so the people developing the exercise, can see. Students can only see this text and also this check mark. Now, any other exercise that is mathematically, or any other answer that is mathematically equivalent to 8 and has a symbol in it will also get this feedback. So like this or like this. And any answer that is wrong will still be wrong. But this wrong is also, well, it's not really nice because the student, if he gets wrong, it's not really motivating them to try again. So we want to fix that as well. And then we go back to the feedback system. So we just had a positive feedback part of the tree. Now we go to the negative feedback part of the tree. So what if the student's answer is not mathematically equivalent to the solution? Well, in that case, the computer will look for negative feedback rules that are applicable to the student's answer. And if there are any, it will display them. And if not, then it will just say wrong. And this is what we just saw. If I typed in 7, then it would just say wrong. So we could maybe make a negative feedback rule just to motivate them a bit more than saying wrong. So we go to negative feedback. And of course, this is a really easy exercise. Like at the higher level, there's not too much you can do wrong with adding 3 + 5. But let's just say we want to make a rule that checks if the answer is almost correct. So if it's 7 or if it's 9. Then we again choose our evaluation type. So right now I'm going to choose eval numeric, this one. And I fill in the definition, which is the correct answer, and the precision, which is 1. And if I use it like this, then all the answers between 8 - 1 and 8 + 1 will trigger this feedback rule. So basically anything that's 1 of the correct answer. And again, I type in a feedback text like something like this. Okay, so we view the exercise again, and we're going to see if this feedback rule works. So now anything that's between 7 and 9 and not the correct answer, we'll get this feedback. So I'll try 7, for example. It says almost correct, please try again. And we see here that negative feedback rule 1 is displayed. With 9, it works the same. But if we put in an answer that's not between 7 and 9, it would say wrong. And what we do at SOWISO is if we make an exercise, we try to make the feedback such that with whatever answer the student gives, we always try to help them like get to the correct solution themselves, a bit of this guided discovery. But now with this platform, you've seen how we could do it from scratch. Let's see. So we did the feedback. And another nice feature that I showed you before is that whenever I refresh the exercise, the numbers change. And in this case, that's not the case yet, because anytime I refresh it, it's still 3 plus 5. So we will fix that as well. And for that, we need a fourth tab. So we need the variables. And in this case, in this exercise, we will need 3 variables. So we will need one for 3, one for the 5, and one for the solution, which is the sum of the first 2. So we add 3 variables. And then we say what they need to be. So the first variable is a random number between 1 and 9. And the second one as well. And right now, the first variable is called $A. That's why the dollar signs were taken for LaTeX. But if I click it, I could give it a different name. For example, $number 1. And I call the second one $number 2. And then the third variable is number 1 plus number 2. And you can see that indeed the first variable right now is value 7. The second one right now is value 4. So the third one has value 11, which is the sum of the 2. And we give this one a name as well. We name the solution. Now, what I type in this definition field, right now this is PHP code, which is not really friendly for mathematical calculations. So what we can also do is instead of using PHP, we can use Maxima, which is a computer algebra system. It looks a lot like Mathematica and MATLAB and these kind of languages. We can also use Python, and we can use R, which is a statistical programming language. So if you want to use this at some point, you can just use whatever language you're most comfortable with. And if that's none of them, then we will gladly help you out with learning either of them. And also, like a bit of explanation on how to use this programming language can be found in our help center for teachers that are struggling at the beginning. So to go back to the exercise, we've made our variables. And if I click new variables, then you will see that they changed. Right now it's 3, 1, and 4. Now it's 5, 4, and 9. So the last thing we need to do is to put these variables back in our exercise. For example, in the text tab. So everywhere where it says 3, we have to change it to number 1. And everywhere where it says 5, we have to change it to number 2. Like this. We did it for the other fields as well. So this is equal to solution. And as you can see, we've now changed all our text fields. So then we just need to change our feedback and our solutions. So here the feedback, instead of 8, we put solution. In the positive feedback, we didn't use any numbers. And then in the solution, we also need $ solution as the variable. And then we feed the exercise again. So right now you can see that our new variables appeared. The solution also changes accordingly to the variables. And if I click this blue button, if I hover over it, it says restart the exercise with new variables, then indeed the numbers will change. So right now the answer is still 9, but if I click it again, well, now it's something else, 13. And the feedback also still works. So if I would do something that's one of the answer, like 3 or 5, then it will say almost correct, please try again. And if I would use a plus sign, oh, that will tell me to simplify. So this is, in very short, a way to make an exercise from scratch. And like I said, if teachers decided they want to author their own material on our platform, so not just use the exercises that we have already, but actually make their own, then they always get a training where we explain how to do this with a bit more detail, and they can practice with it and ask our support team some questions. Now let's see. Yeah, so I'll just round it up. And then at the end, take some questions. So if you're interested in this platform, either because you want to use it as a teacher, or if you want to author your own material, like make everything from scratch, that's all possible. So what you could do is you can book a demo with one of our math education specialists. So what happens is that we'll just have or one of my colleagues, for example, Adam, who gave the talk last year, he will get a call with you, and then he can show you some more features of the platform, and also maybe tell you how SOWISO could help you solve your teaching struggles. So maybe you're struggling with a class that's not participating well, or any other problems, and then we can see if you can help. We can help you out with that. Also, like I said, you can use your login credentials at home for the next month, so you can try it some more of the exercises, or maybe the different exercise types. And what's also good to mention is that we offer 6 months pilot projects for free. So if you think, well, I'm teaching this class at the university or the high school, I'm not really sure if SOWISO is a fit for me, but I want to try it anyways, then you could maybe do a pilot with us. And then I'd just like to end for now. I know it's short, but we're just with a few people, so I guess I think it's more fun for you to just try that at home with the credentials you got. Yeah, and thank you for your attention. And if you have any questions, feel free to ask me.
I'm just going to jump in there, Amber. I've stood in for Christine, who's gone off on parenting duties. Yeah, just to say thank you very much for the demonstration. If people do have questions, there's the EAMS Matrix live chat, so you can pop some questions in there. Well, we're quite a small group, so I guess if you want to come, if you want to ask a live question, stick your hand up or whatever, then go for it. You can unmute.
I've managed to get away from the kids for a couple of minutes. I've got a question. I'm going to be asking quite awkward questions as a developer of another e-assessment system. What I'm
Go ahead.
Was interested in the quite long list of they're called exercise tests, the things you use to check the solution at the end.
The evaluation types, yes.
Evaluation types, yeah. So what I'm interested in is how often are you just reusing an evaluation type, and how often are you is one of the developers having to make up a new evaluation type for you? And is there like an intermediate process where you're writing code and then eventually it gets turned into an evaluation type?
Yeah, so there's a few evaluation types that we use very often. For example, the eval normal. There's also the possibility, and I can show you that. Yeah, I'm a bit struggling with my screen, but we have the evaluation types eval Python and eval R, and also eval statement, which is like for maxima. And what this does is that if you, for example, choose eval statement, then in this definition field, you can write any maxima code or Python or R code, whatever you want, and you can basically write your own evaluation type. So either for the solution or for the feedback. So if any of these evaluation types, like if they're all not really fitting for you, or if they don't do exactly what you want, then you can just write your own. And this is what we often use instead of actually having to go to a developer and ask if they want to make something for us.
Okay.
Does that answer your question?
Yeah, it does. It does a bit. I think. I think that one of the values of having these kinds of systems is having stuff already made and reusable. And it looks like SOWISO has a lot of things ready to reuse. So I expected the answer to be something like we hardly ever have to write custom code.
Well, that's also true, because if we write a new exercise, then there is a bunch of other exercises that we've written before that actually have something similar. So what we then do is just copy the old exercise, change some things, and then we have something new. So we barely ever have to really start from scratch as we did right now, which makes developing a lot faster, of course. And also for teachers that would decide to author their own exercises, that they can also copy our exercises and change them. For example, if they only want to change the text or only want to change the grading scheme or maybe some other stuff, then they can do that and they don't have to make something new.
I don't know if Chris wants to read out the next question or if I've taken over again.
Yeah, hard to know. I'll do that, Chris, in case you have children here. Child here is definitely under control. So Ingo down in the matrix chat asks, how do authors implement scoring?
All right, that's a good one to show. I can do it here. So for that, we need to go to the feedback, either the positive or the negative feedback ones. And with every feedback rule, there is this little box that says text usage. And what this does is that if you put in a percentage here, for example, 50, then every time, well, if you would use this exercise in a test and the student would trigger this feedback rule with our student answer, then they would get this percentage of points for the question. And by default, only the actual correct answer. So let's see. Only in this case, they would get 100%. And in all these other cases, they would get 0% on the exercise. But if you want to implement partial grading, then for every feedback rule, you'd have to just say how many points the student would deserve if they would trigger the feedback rule.
That's great. Hopefully that answers that question. Keep them coming, please. If you want to stick a hand up or pop something in the matrix chat, I'll ask one if that's all right. The language option that's at the top there, is that about the editing interface and all the how does language work with the from the student side?
Well, we can change language. Like as an author, you can change the language. So I can just maybe put it on Dutch for a second. And you see that the text disappear because we have just changed the language. What we often do is that we translate our exercises and our courses to different languages. So students can choose between any of these languages and then get the whole content in their own language. So this is for both students and authors and teachers.
So I'm right in saying you would rewrite the prompt in the Dutch in that case?
Yes, so here it says please simplify, and then we have this translate button.
Yeah, okay.
And then we have a translator that just translates all the texts to whatever language you want to translate the course to.
Nice, thank you. So follow up from Ingo in the Matrix chat. How can tests be configured? So like things like the number of attempts or late passes, like students submitting late, randomization of questions.
Well, this is actually something that my colleague talked about last year quite a bit, but I can try and show you because I'm more of an expert on the authoring platform, but I can try. So to make a test and to change these settings, we can go to the teacher and then click on tests. And we can schedule a new test or make a new test. And then what we have to do first is we select where the test exercises come from. So if you just choose test material or course material, you can choose exercises from the course material in your test. But there's also two different options. Then we select the exercises that we want in the test. So for example, if we make a test about differentiation, we could just pick some exercises from your course. If you don't know what they look like, click the plus and you get a little preview. And you see them appearing up here. So you can add another one and it's added here as well. And this is put in a section. And what we can do with these sections is that for every question, we can say how many points they're worth. So for example, if this one is a bit harder, maybe you want to give it 2 points and the other one's 1 point out of 4 in this case. They're automatically randomized, so you don't have to do anything about that in the test. Of course, if you don't want randomization, you can just make an exercise or copy one of our exercises and turn off the whole randomization. But we always see that the teachers do want the randomization part. And then what you could also do is, for example, you want to give the students 2 questions about the difference quotients, but 2 random questions. You could put a filter here. So if I put it at 2, then every student will get 2 from these 5 exercises in their test. We can add as many sections as we want. So this section can, for example, be about a tangent line or something. And this is how to make a test. And then we have some other settings. So the language in which the test can be taken. So for example, if I only enable maybe Dutch and English, then the student will only be able to select Dutch and English here in the test settings. Date and time, so when they can start the test, when they have to submit the test, if there's a deadline. So for example, in the Netherlands, it's the case that if students do exams, they can start from 10, but they can also start a bit later. But they have to end at a certain time. So then you can put a deadline. Also the time zone, very important. You can name the test and give the students some information either before, during, or after the test, depending on their score. So for example, if their score is, I don't know, from 80 till 100, you can say, well done, or something. And information before the test begins could, for example, be, well, for this test, you can use a calculator, just take it out of your bag and put it on the table or something like that. And then as a last step, we have the settings. Oh, I have to select the date, otherwise it doesn't work. Something like this. And here we have all the settings to make the tests as you want. So, for example, you can make a test and make it unavailable for now, but then make it available at a certain date, or maybe make it available after they have completed a set of exercises. You can change the number of attempts. So you can give them 1 attempt to the test, 2 attempts, or maybe unlimited if you just wanted to keep practicing and then the highest score counts. You can say how much time they can do, they can take for 1 attempt. And something about the results. So you have these options if you want to release the results immediately, or maybe some teachers, they want to let the computer automatically check their exercises, but then also go through it by hand, just to make sure, for example. then you can do custom. So then you actually have to check release after a student's test name, and then only then the student gets their answers. Minimum passing score, some other options, and then some tools. So for example, the options to let students upload files during the test. For example, if you want them to input the correct solution or the solution that I think is correct in SOWISO, you can let them take a picture of their worked out solution. So if what they type in their answer is wrong, then you can maybe look at the worked out solution and then give them some points if you don't want the computer to do that. And we can do some options about security. So for example, let's see, restrict with a password, or maybe disable all other internet pages, but only allow SOWISO so that they cannot look up answers online and things like that. And that's actually how to make a test. And then you can distribute this test to students, and they can make it. I hope that answers the question. It was a bit of a long answer, but
thank you, Amber. That was really thorough. Useful, thank you. We have two more questions in the chat. Christian, I'm going to demote you to the end because I think it's a good question to finish on. Question from Chris Stewart: Can units be included in questions? In the answer to questions?
Yeah, so the answer is yes. I can show you very short how that works. So we have actually an evaluation type for that. Let's see it here. So for example, in solutions, I'll just add another solution, but just to show you how it works. We have eval units. And how that works is that you can say, for example, the answer is 5 meters. Then the student will actually have to put in 5 meters as an answer, or otherwise it will not be seen as correct. And this is automatically like the one we've seen with eval numeric. So we can put in a precision, for example. Well, I just leave it at 0 for now, but maybe you want all answers between 4.9 meters and 5.1 meters to be correct, and you can change it here. And then the student can actually use this. Oh, let me just move this a bit. They can use this virtual keyboard. If they click unit, then I can use this unit box and actually input first a number and then the unit that belongs to it. Right now it's just please simplify because we have these positive feedback rules, but you see that the solution works. What's nice about this is that well, you could put this box here already if the student starts the question so that they don't have to click it. What's also nice is that if I put it in a different unit, but it's also correct. I hope that this is correct. That will also be seen as correct. So either 5 meters or 0.005 kilometers, or the same with kilos and grams and other things. And a lot of units are supported. And as you can see, I can type them on my keyboard like this, or I can use this virtual keyboard to put in the units.
Great, thank you. So a good place to finish. I think Christian's questions. What are your plans for development in the future?
Oh, that's a good question, actually. Because our development team is, of course, separate from the authoring team a bit. But what we've worked on in the past is Python type exercises, so the automatic checking of Python. And I think the main authoring project right now that we're running or going to run is kind of an authoring platform that's even more accessible. So it is a bit less options, but it's also way easier to make exercises or to change exercises. Like as if you would have this magic fill-in button in Photoshop that it just, you click it, it creates something, and then you could change some things, but it makes it easier to actually make exercises. And of course, we take requests from clients. If there's a big client who says, well, I would like to have this exercise type, then we can look into it, things like that. But I'm not sure if I 100% correctly answers this question, because I'm not entirely sure what the development team is working on right now. But this is about it, I think.
Wonderful, thank you. That seems like a good place to finish. Thank you, everybody, for coming along, asking questions. Thank you to the SOWISO guys there for that excellent demo and answering those. If I could just have a look to the program tomorrow. I'm going to end your screen share there. That's all right.
Yes, of course.
Okay, so we've got sessions, 2 sessions again tomorrow. So 9:30 UK British Summer Time. We have 2 shorter talks, testing on equality. Oh, I'm just going to test my pronunciation here. I'll say confidently in my German Geordie, Hendrike Schmidpott-Schultz, on testing on equality, and then maths e-assessment support in Rhineland-Palatinate, Germany, by Dr. Ingo Dahn. And then in the afternoon, chatbot as students partner in mathematical problem-solving assessment by Blazhenko Divjak. So we look forward to seeing you at sessions tomorrow. And thank you again for coming, and hope everybody enjoys the rest of the day.